Hello student, in this lecture we have to start the new point, that is effect of impurity and temperature on surface tension. Okay, in the previous lecture we have to study what is mean by how the shape of drop is decided. Okay, and for that I will explain the three surface tension forces are responsible to decide the shape of drop. First surface tension is due to solid and air interface. Second surface tension force is due to solid and liquid interface, and the third is liquid and air interface. Okay, so after that we have to start the next point on our board syllabus, and the next point is effect of impurities and temperature on surface tension. Okay, when you add any impurity means impurity is the substance which is not the part of that solution. Okay, so here you can add some impurity in that given liquid and study what is the effect of surface tension when you add that impurity. The impurity are so many times, some impurity are soluble, some impurities are highly soluble, and some impurities are not soluble. Okay, then what is the what is the effect of that impurity when you add impurity in that liquid? Then what is the effect on surface tension of the liquid? So in first point, when you add soluble impurity, and here you can consider only the water solution. Okay, so when you add soluble impurity means NaCl. Okay, when you add NaCl in the water, then what happens? The surface tension of water increases. You know that the sea water and river water, sea water is a salty water, river water is a sweet water. Okay, so surface tension of sea water is maximum as compared to river water. So you can easily swim in sea water as compared to river water. Okay, and the reason for that easy swimming is the surface tension. Surface tension of sea water is maximum as compared to river water. So first point is, when you add soluble impurity, that is NaCl, the surface tension of liquid increases. Now we move the second point. When you add sparingly soluble impurity. Sparingly soluble impurity means feebly soluble, that is weakly soluble. When you add weakly soluble impurity, for example phenol or detergent, okay, phenyl detergent, that impurities are slowly mixed with that solution. When you add this sparingly soluble impurity in the water, then surface tension of water goes down, that is it is decreases. That is the surface tension of pure water and the surface tension of soap water. In that case, surface tension of pure water is maximum as compared to surface tension of soap water. You can add detergent in the water so that its surface tension decreases, and when surface tension decreases, the water is spreads easily. So the washing action is for better washing action, you require the low surface tension of the water. So you can add detergent in that water. Okay, so the second point is again, when you add sparingly soluble impurity in water, the surface tension of water is decreases, and means sparingly means phenol or detergent. Now the third case is when you add insoluble impurity. Okay, insoluble impurity. When you add insoluble impurity, the cohesive forces between two molecules of water is decreases, so its surface tension is also decreases. Okay, this is the third point. Insoluble impurity, surface tension decreases. Soluble impurity, surface tension increases. But sparingly soluble or feebly soluble impurity, surface tension decreases. Okay, now what is the effect of temperature on surface tension? When you heat the liquid, then what happens? the liquid molecules, the bonds between liquid molecules are weaken and weaken. Okay, and the surface tension is the property of liquid which is due to the cohesive forces of attraction between the molecules. If these cohesive forces are weakened, when you heat the water, the cohesive forces are weakened, and when cohesive forces are weakened, the surface tension decreases. That is, when you heat the liquid, or for example water, the surface tension of water is decreases. It is zero at some particular temperature, and that temperature is known as critical temperature. Okay, and you remember this relation. The surface tension, this is the T, that is the surface tension of water at any temperature, is equal to T0, that is surface tension at 0 degree centigrade into 1 minus alpha into T, where alpha is temperature coefficient of surface tension, so constant hai, and T is the rise in temperature. You can heat the water from 0 degree centigrade to T degree centigrade. Okay, therefore this is the relation. And also there are some liquids which are shows the increase in surface tension when you heat that liquids. For example, molten copper or cadmium gives shows the property when the temperature of molten copper increases, its surface tension is increases. Surface tension is increases. Molten copper and molten cadmium shows increase in temperature due to heating. Now we move the next point, excess pressure across the free surface of liquid. Okay, in that point we have to discuss the three surfaces. First, the plane surface, second, concave surface, and third is a convex surface. Okay, and we have to study, if this is a plane surface, then this is the point A which is just outside the surface, point B is just inside the surface. I will show these 2 points, A and B. Okay, this is the liquid surface. You check on this upper surface, the force act on that molecule is the atmospheric force, atmospheric pressure. Okay, atmospheric pressure means force, pressure is equal to force into area, therefore force is equal to pressure into area. Here, that is, this is the molecule on the surface, and A and B are the point just outside and inside to the liquid surface. Also, I will show the forces due to surface tension act on this molecule. You check carefully, the force due to surface tension on this molecule which is present on the liquid surface is 0. Why 0? Because the total left force is equal to right force. This is the molecule. The molecule is pulled towards left, and also the molecule is pulled towards right. The net force due to surface tension on this molecule is 0. Okay, and so the pressure or the force at point A and force at point B is the same. इथं जो काय फोर्स आहे तोच फोर्स ऑब्वियसली इथं असणार आहे, जास्त लेवल मध्ये काय डिफरन्स नाही, ॲटमॉस्फेरिक प्रेशर मुळे असणारा फोर्स आहे. ओके, इफ फोर्सेस आर सेम then pressure is also same. Therefore, for plane surfaces, the pressure at point A and pressure at point B, that is just inside, just outside, both the pressure are equal, and there is no pressure difference between inside and outside point. Therefore, I will write PA minus PB is equal to 0. Therefore, PA is equal to PB. This is the short note. The resultant force due to surface tension on molecule on the surface is 0. If this force is 0, then the force due to atmosphere at point A and at point B is also equal. That is, pressure difference is 0. Okay. So we have to move next point, concave surface. Okay. In the concave surface, this is the concave surface, this is the molecule. You check carefully. The surface tension force is always act tangentially. I will draw here, this is the molecule, I will draw the tangents. If this is first tangent, this is second tangent. Now these are the tangents. Okay, and if you take the components, This is vertical component, horizontal component. Vertical component, horizontal component. Horizontal components are cancels each other. Vertical components are add each other. Okay. Now you check what happen at force at point A, which is outside the surface, force at point B, which is inside the surface. Okay. You check carefully. A is the outside point, therefore the surface tension force is not effective here. Here the force at point A is only atmospheric pressure force, but at point B, this atmospheric force and surface tension force are in opposite. Okay, so here at point B, this atmospheric force decreases slightly, and if this force decreases slightly, that is pressure at point B is also decreases slightly. That is, you can say that the pressure at point A is slightly greater than pressure at point B. So I will write the summary here. Fr means the resultant force due to surface tension on the molecule present on liquid surface. Fr due to surface tension act in upward direction. You check carefully. Surface tension force, resultant surface tension force is act in upward direction, and the atmospheric pressure force and the resultant surface tension force are in opposite direction. This word is important. Are in opposite direction. That is, the force at point B is slightly less than the force at point A. So pressure at point B is less than pressure at point A. That is, at A the pressure is maximum. At A pressure is maximum, and you can easily imagine that if this is the surface and I will exert a force, so that this is the concave meniscus. तुम्ही मला सांगा कुठला फोर्स जास्त असणार आहे? हा फोर्स जास्त असला पाहिजे ना. खालून एक फोर्स, वरून एक फोर्स. सरफेस प्लेन असेल तर टोटल अपवर्ड फोर्स, टोटल डाऊनवर्ड फोर्स दोघं इक्वल असायला पाहिजे. पण जर का हा जो अपवर्ड फोर्स आहे हा लेस असेल तर तुमचा जो मिनिस्कस आहे तो असा होणार. बरोबर. हा फोर्स जो वरनं दाबणारा जास्त असेल सरफेस वरती, तर हा तुमचा मिनिस्कस असा होणार आहे. इन दॅट केस द आउटसाइड फोर्स is maximum as compared to inside force. Okay, and you already the pressure at concave side is always maximum as compared to pressure at convex side. Concave आपण कुठून बघतोय? वरून बघतोय आपण काय, त्यामुळे हा मेनिस्कस आपल्याला concave दिसतोय. Okay, now we move the last third property, third case, concave surface. Okay, in case of concave surface, this is the concave meniscus, this is the molecule on the free surface of the liquid, and you draw the surface tension force which are act on the molecule. Okay, and you check carefully the tangential force, that is surface tension force, are move in downward direction, You can take the components of this force. One component is here downward direction, one component is horizontal, one in downward direction, one component in horizontal. Horizontal components are cancel each other, while the downward components are add each other. Now you check carefully. This is point A, and at point A the force at point A is due to atmosphere. I will show that force by Fa. Also at point B atmospheric pressure is present, but extra downward force is also present, and that extra downward force, that is Fr, is the resultant force due to surface tension. So here at point B, the force at point B is slightly greater than force at point A. This implies that the atmospheric pressure, not atmospheric pressure, this implies that the pressure at point B is maximum, or it is greater as compared to pressure at point A, and A is the outside point, B is the inside point. Okay, this is the convex side, and if you see from downward direction, this is the concave side. Again you check the pressure at concave side is maximum as compared to convex side. Here I will draw the summary. Fr, that is the resultant force due to surface tension, act in downward direction. So Fa and Fr is in same direction. You check carefully at point B. Fr and Fa are in same direction. So the net force at point B is greater as compared to force at point A. That is, pressure at point B is greater than pressure at point A. Okay, so for curved meniscus, the pressure on concave side is always greater as compared to pressure on convex side. Okay, this is all about the point number 2.45 Maharashtra textbook syllabus, page number 40. Okay, in the next lecture I will explain Laplace law. The next lecture is on Laplace law. Okay, thank you.